let's write a code for a problem where we want to find a maximum value from a list. So there are a list of numbers and we want to find out what is the maximum value in this list. And we have a list of numbers. So we have 4, 8, 4, 8, and 7. Let's add 2 here also, then we have more to change. And let's try to write the code. The solution is shown, but let's write it from scratch. So basically I will add the same numbers here, 2, 4, 8, 4, 8, 7. I will change also this value to 3, for example, then there is more to change. And how we would do it. The same problem can be thought, or you can think how you would solve this problem yourself. So you have a list of numbers written somewhere, and you have to find out what is the maximum value of those numbers. So basically what we do in our head is basically we start from here. Usually we start from left to right, but maybe someone starts from the right side. Maybe the numbers are on several pages, so the order how you go through them can be different. But for the computer, the easiest would be to go from left to right. So you take the first element of the list, the second element, and so on. And if you follow this order, then it doesn't actually matter which order you use. You probably in your head try to memorize what is the current maximum value. So let's have 3 here also. And what happens? That, for example, let's say the best value in my memory is stored here. I memorize that the best value is 2. I get here, I say no, the best value is 4. I get here, because my best value is currently bigger than this current value, I don't change my best value. I still know that the best value from the beginning to this part is 4. Now I get here, the 4 is the same I have, so there's no point to change this value. Now I get here. So the 8 is again better than my value, I will replace it with 8. And I will continue, the 7 is lower that I currently have, so I don't change my best value. So this is the mechanism you probably use in your head. You may think about it differently. Often when you solve those problems, you don't think about how you do it, you just do it. But for a computer, you have to actually write every detail, how to solve this problem. So, and in most of the cases, it's nice to think about how you would solve it yourself and what are the steps you do in your head. So it's not, I was just looking over those numbers, I can see that 8 is the largest number. This is not correct. I mean, maybe, yeah, currently there are only 6 values. You might get an overview of the numbers and quickly see that the 8 is the biggest, but still you probably do something similar in your head when you look over those numbers. So you take every number, you compare it with the current maximum value which is stored somewhere in your memory. So let's write the same code. And we want to have the current best number. When I started drawing this, I used the empty box here for the best value. And this is okay for to just show how it's working, but for a computer we cannot have an empty value. Or well, we could, but we should probably store something in this value. In this variable. Let's write 0 here currently. And now we have to go over all the values. So for number, this should be numbers here. For a number in numbers, we do something. We can print it out, but there is no point to do that. We compare it with our best value. So if the current value, if the number is bigger than our best value, then we will overwrite this best value. We will write the number which we are currently checking into this box or into this variable. Best becomes the, or we store the number value into variable best. And later on, after the loop, we can print out the best value. Max value, best. And we can try to execute this code also. And we see that the max value is 8. If we see the code here, it's basically the same, but one difference is here, that I don't use 0 for max number. Why is that so? So let's say if all the numbers are negative, then what is the best value, or what is the maximum value? So the maximum value is actually this one here. This is the highest or closest to 0. But if I initialize the best as 0, I would compare if the -2 is larger than 0. Because it's not, then I won't change my best value. So I already have thought that the best value so far is 0, and now I'm comparing this to every other number. But this is not the case, so this doesn't work. So instead, I could say that the best value is the value of the first element. So I will put the first element into this best value. Then it's guaranteed that I always get the solution, because with 0 I don't get the solution if there are negative numbers. Then yeah, someone can say, okay, let's put very small number or a high negative number in this best value. But what if all my values are still lower than that? So there's no limit. I mean, actually it would be nice to have indefinitely small or negative number here. Then everything, whatever will be in this list, it's always larger than minus infinity, and we get a result. So instead of using minus infinity, we'll just use the value of the first element, and we can do it like that. Numbers 0. The only problem is that if the numbers is an empty list, I would get an error, because I cannot take the first element of an empty list. But in case the list is empty, it's anyway questionable what is the maximum value of an empty list. So it's probably not undefined or something like that. So it's either way, you should probably do some additional check for that. If the list is empty, then print out that there is no maximum value. But then in other cases, using the first element as the current best value is quite okay solution. And here, if we execute the code, we get the maximum number is 8.